Good morning, students. In the last class, with respect to laboratory, we have discussed two programs. The first one, resonance line drawing algorithm, and the ninth one. Actually, that is ninth one. So that is general scanline polygon fill algorithm. According to your syllabus, it is a ninth program, but we are executing our lab program based on the whatever the topics we are covering in the theory classes. Then it is meaningful. Then you will understand. Okay, so instead of going in the proper in the order according to the syllabus, no use. Okay, so based on the topics covered, we are going to execute the same programs in the laboratory as well, so that it will be correlating and you can easily understanding in both the ways. Okay, so in the same fashion we are moving to the next third program. So that is in your syllabus, it is a second program according to our flow. It is so the third program we are doing. So this is a second program in your syllabus, that is create and rotate a triangle about the origin and a fixed point. Okay, so what we supposed to do, we have to create a triangle, and we have to rotate that triangle from the origin and also with respect to some fixed point. So two cases are there in this question. Okay, so that is what we supposed to perform in this program. Okay, so before that, already we have discussed in the two-dimensional geometric transformation. That is how we are going to perform the rotation operation for any geometry, not only triangle, any geometric objective, any polygon. So basically it contains, as I said, three steps. We are going to translate to the original point, and again rotation will takes place, and again inverse translation is going to be takes place. Three steps. So for first one is translation to the origin with respect to origin, and again rotation, then after that inverse translation. Okay, so that is T inverse, T or T inverse. These are the three steps we are going to perform in this case. Okay, so that is we discussed in the theory class with the example. Okay, so same thing we have to execute in our lab also. Practically how we can able to execute this. So as again same thing, we have to include all the headers, required headers. Okay, so stdio.h, stdlibrary.h, math.h, and glut.h. Okay, and we are initializing your triangle. So that is the vertices in terms of an array. So that is triangle of three vertices. This indicates three vertices. Okay, and these are as we are considering all the three different axes. Okay, so that is x1, x2, x3, because three vertices we are considering the corresponding value. This is not like x1 y1 z, x1 y1, sorry, x naught y1, sorry, x naught uh, y naught, and another z naught, not something, not this is not like that. Okay, so this is completely, so all the x values of all the three vertices. Okay, that is first one is like x1, x2, x3, like that. Next y1, y2, y3. Next another third coordinates, the third vertices. Okay, what is that, another value. Okay, so like that we are going to specify in terms of an array. Okay, so these are the three set of vertices we are going to specify for the triangle in terms of an array. And we have the rotation matrices of like 3 3. So the given value initially is 0 0, and again result where you are going to keep those values that in the result matrix, that will be again initially we're going to initialize to 0 0. Okay, and we have two variables h and k. So in order to find out the centroid, there we are going to assign the values for these variables of your x and y to the h and k. Okay, so next we need another theta, that is the rotation angle, and we are going to convert this theta degree into the radians. That's why we need one more variable rad, that is about radians. Okay, and as we have two choice, because they are telling about the origin and about the fixed point, that's why I'm using the choice option, that is int ch. So we have to specify. So these are the variables required and array declaration with respect to the construction of triangle and the resultant matrix and the rotation matrix. Okay, so just we have declared and initialized to some value. So here actually we are giving the input values. So through this, okay, so default matrix is going to constructed with this value. If you want to construct some other, then you have to change the values here and you have to execute the program again. Okay, that is what the data we are passing through the program. Okay, so through the command prompt we are going to give only two inputs. One is rotation angle and another one choice. So we are going to give the choice either one or two. So one means about the origin, two means fixed point. Like that we are going to through the command prompt we are giving the inputs. But triangle construction, everything vertices values we are passing through the program only. If you want, you have to change the values here and you have to execute for some other different input values. Okay, so that's it. So next we'll directly move on to the main program because it will start from that. Okay, so that is again in main inter, it is taking the arguments through the command prompt. And as I said, I'm going to provide the input like rotation angle. So again, so floating value, it's some percent theta. And again I told we have to enter the choice, that is one means fixed point, two means origin. Okay, you can give whatever you want, you can just rearrange the option also based on the coding. So you have to modify. So yeah, in this case I'm considering if you enter the choice one, it should rotate about the fixed point. If the choice is 2, it should rotate about the origin. That's it, simple. So next after that I want to convert my that angle, that rotation angle, the theta, that is measured in terms of an degree. So I want to change it to radians. That will be calculated using this standard formula, that is radians equals to theta into the pi value divided by 180. Okay, so 3.14 divided by 180. This is a standard formula. How to convert your, that is the angle theta into radians, degree into radians. Okay, so next again same thing, it is going to initialize the glut in it. Okay, so next glut display mode, again this is a two-dimensional and it's of RGB. Next glut window size I'm specifying, glut window position, again repeating, these are all default functions repeating we are. Okay, so next is again glut create window. Here we're going to give the name as triangle rotation. So because we are working on that, so just this is the naming so I'm going to give the title as triangle rotation. Again it is going to initialize the display function. Okay, so now I will move on to the display function. This anyhow, this initialization, that projection window, everything will be automatically takes place, but the main the control will go to the next is display. Okay, so I will go to the display function. So this is already. So same thing, this is everywhere same function we are going to use. So no need to tell again and again. So same thing, clear color, color 3F, point size you're going to specify, matrix mode is of GL projection, load as the identity matrix, and it is of two-dimensional object. So this is the initialization you're going to do in the projection view. Next what I said, so it will go to control, will go to the display. Okay, so next will from main function, the control will come to this function, the white display function. So in display function, as I said, it is going to clear the GL color buffer bit is a constant, so we are going to use to clear the buffer, color buffer in the projection. So next, as I said, I'm going to just assigning the radians, that so that is theta equals to radians. So your value, so radians you're going to assign to the that theta. So whatever the value you're going to calculating. So next color 3F. So this GL color 3F. The 3 means 3 parameters I am passing. Okay, and F means floating. The data type float. That is what 1.0, 1.0, 0.0. So what is this? So this is the equal mixture of the equal proportion of red color and equal proportion of the green color, RGB, right? R and green, R and G is present, but blue is absent. So if you mix these two color equally, so you will get the yellow color. So that is a combination. If you mix equal proportion of red color and green color, you will get the yellow color. Okay, that means your initial triangle, whatever you are going to construct, the initial triangle, it should be in yellow color. Okay, because we have to identify, we have to differentiate what is the initial triangle and what is the rotated triangle. So in order to differentiate, just I want to make it clear. So that I want to fill my triangle with a color, some color. So just in this case I have considered the yellow color. So yellow color, if in order to get the yellow color, what we have to do, we have to make the R and green as present, and the blue color will be absent. Okay, so this will gives the yellow color triangle. Okay, so next draw triangle function will going to call draw triangle of triangle. Okay, so that will go later. So look at the choice. If suppose choice is 1, so if suppose choice is 1, so what is the choice 1? What it is saying, fixed point, about fixed point it should rotate. So that initially I am going to assign my values, that is to h equals to 100 and k is equal to 100, height and width. So just you are going to specify the value, that is 100 comma 100. This is nothing but x comma y, the coordinate values. This is nothing but your x and y coordinate values. Okay, so next it is going to call the rotate function. So we will go to the rotate function. Yeah, so same thing I have written here. So main function, so theta radians. Next go to the this one color, so equal color, same thing I have explained already here. Here actually the control is here now. So the fixed point will be like x comma y, h comma k. So this is the some position you are going to specify where that fixed point, where that triangle is going to be constructed, that centroid you have to specify. Okay, that is 100 comma 100. So that is the value they have initialized here. Next rotate function is going to call rotate function will perform. So we'll go back to that rotate function, how it will be that is working. Okay, so we are going to consider m and n value, the variables we want. So in order to calculate the, so we know the equations for that, right? So expressions we have discussed in the rotation function, same thing. So just I will do that, the value will be in terms of matrix. I want to put just same thing, I'm going to put it in the equation format, that's it. So for that I'm going to finally assign those values to some other variables. So that's why I'm taking as m and n for that. Okay, so this is the formula we are going to use. So I will show that the diagram you can just easily understand. Look at this diagram here. This is what we discussed in the class also. So 2D composite transformation. See, look at this. This is the specified position xr comma yr. Okay, already you know. So we have discussed. So same thing, original position of the object and pivot point. Okay, this is at some point. So now next is I want to bring to that origin. Okay, same thing I have translated. This is the first operation, translation. Translation of object. So that pivot point xr comma yr is at now origin. So initially it is at xr comma yr. Now it is at x0 comma y0, x0 comma y0. That is at the origin. So next after that again I performed here. I want to give the rotation angle so that it is rotated for some degree. Whatever the inputs we are given, according to that it will rotate. So rotation about the origin, by making this as the origin, so reference point, and it is going to rotate. So after that what I have to do, I have to perform the inverse translation. So this is the translation, how it takes place from here to here. Now here the object is there. Now I have to in order to go back to original position, I have to perform inverse translation, means it will go in the opposite direction. So same thing, see, after rotate just it will go like this, because original position is here, the fixed point is here at suppose 100 comma 100 in my example. So now it will move to here. So that is what that now. So this rotation happened. Okay, so like that. So we are going to perform the transformations, okay, or rotation. So and the corresponding matrices is given here. So these are not required, directly you final equation you find out. So based on this we are going to write this code. So rotate, so the value same thing here. So h, so what is that, 1 minus k into sine theta. So same value I'm going to consider as theta minus 1, next plus k into size. These are the variables. Okay, just I'm considering h and k are the whatever the value I consider. H is equal to 100, k is equal to 100. Those are the fixed points. I'm going to multiply with cos theta again minus sin theta. So similarly minus cos theta again minus sin theta. So using this equation I'm going to put it in this format. So I'm going nothing, simply I'm going to consider all these values. I am going to write it in a matrix, 3 cross 3 matrix. Okay, so because this is a, we are considered 3 cross 3 matrix, right? So all these values we are going to put it in a matrix. Just look at this, after this calculation you see here 0 into 0, 0 into 1, 0 into 2. So what is the value? Cos theta. First one is, what is that? Cos theta. Next is what? Minus sin theta. After that m, I'm going to consider the another variable as m. So m means here whatever the value you calculated using this equation. So simply I have put, because this equation, so whatever you're going to calculate, that I will going to put it in a m, because so this value will be stored here m. That is what I'm going to initialize. Next I will go to the second row. So 1 comma 0, 1 comma 1, 1 comma 0 means what? Sin theta. Then after that 1 comma 1 is cos theta, cos theta. Again 1 comma 2 is n. I'm going to consider whatever the next value calculated here, n. I'm going to put it as a n. So next I will go to the third row, 2 comma 0, what? 0. Here, look at this, 0. Next after that, 2 comma 1. So 2 comma 1 also 0. So next 2 comma 2, 1. Okay. So this is how rotation matrix. So using this it is calculated. Understood? M and when n value are calculated using this formula. Okay. That can be put it in this fashion. After calculating those two values, these two values, then I am going to, instead of here I am putting m comma n. That's it. Just you replace this matrix here m, here n, and again cos theta minus sin theta m, sin theta cos theta and n, 0 comma 0 comma 1. Now it contains 3 cross 3 matrix. This is, so for that matrix just I'm initializing my array. So same, that's it. I'm not doing any special here. So for that I'm going to specify the values, corresponding matrix values I'm going to put it in this function. So that is what the rotate function. So if you apply, if you considering this matrix, if you apply the given values and if you calculate it, then this will use the rotated matrix about the about any like a fixed point, or it may be at the origin. Okay, so that is the function we are going to write here. Okay, so just yeah, look at the same thing. So then one example they are consider for another one. You can just calculate from your end for the next another question, but we'll go back to that our program. Okay. So this is how. So this function is written. The rotate function is written by using this concept. Whatever we discussed, the final matrix, whatever we got, that is 3 cross 3 matrix, and that I am going to write in terms of a function coding. Okay. So this is how your rotate function we got. Okay. So just I want to convey the same thing here. Okay, how you got this rotate, how you wrote this rotate function. So based on that matrix, next multiply function we're going to call after that. So next I'll go back to that choice rotate function once gone. Then after that I'm going to put that in some color after rotated. So once it is perform the rotation operation, then I have to distinguish, right? So how I am going to distinguish? With some color. So now I am going to I'm going to put that color for that object like red color. Means the rotated triangle will be looks in red color. Your initial triangle will be what? Your initial triangle will be in yellow color because of this input, and your after rotated the triangle, your output rotated triangle will be in red color because I have specified only red color, remaining two are absent. Okay, this is for choice 1. Okay, next, if choice 2, what will happen? If suppose the choice 2, if choice 2, what I am going to do, it is I am going to same, I am going to take now h and ks. Calculation is like this. What is this? Based on the centroid I am going to calculate. What is that? H equals to, how you are going to calculate? Triangle of 0 0 0 1 0 2 divided by 3. What is this triangle of 0 0 1 0 1 0 2? It is the centroid of the triangle given by the summation of all the x coordinate values. So whatever all the x coordinate values, you are going to do the sum, and you have to divide it by the 3 vertices. Sum means all the vertices x coordinate value are going to do sum, and you are going to divide it by 3. That will gives a h, okay, value. Similarly k, how you are going to calculate? Same thing, the centroid of the triangle given by the summation of all the y coordinates of all the vertices, all the 3 vertices, and you are divided by 3. So that will be given the for the y value. Okay, understood? So this is what I'm just simply I'm doing what? The summation of, summation, correct, right? So plus is the summation of all the x coordinates, okay, of all the 3 vertices. Why we have 3 here means 3 vertices, nothing but vertex 1, vertex 2, vertex, and divided by 3 I'm doing. That is the h value. Next, k is same thing but y axis, that is about y coordinate value. Okay, all the vertices, 3 vertices, y coordinate values, sum up divided by 3. Okay, then I am calling the rotate function. See, rotate function again same thing, that it will go back to that, it will take the h and k value, but h and k values calculation is different. Look at this example here. Just I am going to specify h and k value, but here not I am specifying anything else. Just okay. So then after that remaining is same. Okay. So this is the first choice, that is about the choice is about the fixed point and the origin. Second one is by default it will take from the origin using that calculation of your h and k. Here only the main logic is present in this case only. If choice is one, simple, you see, you just simply understand choice is one, then you have to rotate your triangle about the fixed point. Means you have to specify the fixed point. In this example I have specified my fixed point as x comma y as 100 comma 100. Then I call the rotate function. You know, I show how I wrote the rotate function based on the 2D composite transformation. So using the matrix cos theta minus sin theta m, and again sin theta cos theta n, and then after that the 0 0 1. So using that 3 cross 3 matrix, I initialize my rotation matrix 0 1 0 0 0 1 0 2. So like that I have written the rotation matrix function. Okay, so this is how I got this function. So simple rotation logic is present here, but you should know how it is going, how the values we have derived from that in the function. That's why I showed this example. So this is equivalent to this matrix, this function. Okay, next, after that, so again it is going to draw the triangle, resultant triangle it is going to call. Again GL flush means it is going to draw all the objects whatever we are going, we have constructed so far where resultant objects. Okay, so next let look at the draw triangle function now. How you are going to draw the triangle function. So you're going to draw the, just you're going to matrix value, you're going to give 3 cross 3 whatever the resultant matrix, you're going to pass to this function. Again we know, right, GL begin and GL end. So in order to draw the triangles we need three set of values, right? GL vertex to F, GL vertex to F. Again this is the one vertex, another third one, V1 V2 V3, and the corresponding values, the matrix values we have to consider. In the previous case what we supposed to give, we are going to give the like x1 y1, x2 y2, x3 y3, like, but this is in terms of matrices you are going to specify 0 0 1 comma 0. So like this, so matrices value, these values are computed in the um, previous function. Okay, so after that means multiplication function. So then once it has been executed, your triangle is going to be drawn. Okay, so that is what here. So then we can call the draw a triangle function of result. So the control will go to draw triangle. Here we are specifying the three vertices in the form of matrix. That is what I show here in the form of matrix. Then these three vertices will be joined using the lines polygon. So these three vertices, how we are going to join? So using the GL triangles function. This is an inbuilt function, constant function. So using that we are going to draw that using the GL triangles constant. So this is how we are going to draw the particular triangle. So whether it may be about the fixed point or about the origin. Understood? So next remaining, that's it. So then it is going to display that triangle. Simple. Just in short I will tell. So okay, so you will just have a quick review of this. So it start with the main function. We are going to enter the rotation angle and you're going to give the two choice. One is about the fixed point, two means about the origin it should rotate, and we are going to convert your theta means degree into radians, and remaining all these things how it is going to work perform. Then display function is going to call, the control will go to the display function. Your display function contains so these are the functions. Here I'm going to initialize my initial triangle with the yellow color, and again I'm giving the choice as one. If suppose choice one means about the fixed point I'm specifying here, then I will call the rotate function. How I wrote the rotate function, so that is again based on this concept. Okay, so you can easily understand. So using this rotation matrix and put it in the code, okay, in the form of a function. So then it will be, we are going to derive like this. So once that is done, so again we'll go back to the second choice. Okay, so then the resultant will be in the red color. After rotated, the triangle will be in red color. So next, if choice 2 means you're going to calculate the centroid by doing the summation of the x coordinates of all the three vertices divided by 3, and we're going to assign the values to the h and again k. So again summation of all the coordinate y coordinate values of all the three vertices divided by 3, and you're going to assign the value to k. Again same, calling the rotate function again. Okay, then resultant matrix will be in which color? So this is something different combination. Here it will be red color, but here see your the equal portion of equal proportion of red and blue is present in this case. So don't know which color will get when you we are going to see when you execute the program. So the resultant output will be in this color. Okay, so that is about the origin. So one, then after that you're going to draw the triangle for the resultant values given. So then will control will go to this again, draw triangle here. So here you know right how to. So using the three vertices in terms of a matrix, you are using the GL triangles constant, you're going to construct the triangle. Okay, so along with the resultant triangle. So that's it. Okay, this is about the multiplication function, means how we are going to multiply, as I show right in this. So how we are going to multiply these values, so sine theta, so this calculation, so that multiplication is going to shown in the, that will be carried out in this multiply function. Okay, because we are considering 3 cross 3 matrix, right? That's why it is starting from 0 to 3. Loop will execute 3 times, that is 0 1 2. So when it comes to the 3, so it will come out of the loop. 3 into 3 is less than 3, no, that condition fails. So that is 0 1 2, 3 cases, so 3 cross 3, and you're going to put that value in the resultant matrix. So this is how you're going to calculate. Okay, so that is rotation matrix into triangle. So all these values you're going to calculate it. This is for the um, uh, resultant matrix you're going to store in terms of I comma j. Okay, so this is how your rotation of a triangle matrix is going to work. Then we'll go to the execution part. So this is the same function we have using here. Okay, same program. Just go to this build solution. Okay, next execute this program. So it will ask for the rotation angle. Just I'm going to give 90-degree, and it will ask whether you are going to rotate about a fixed point or origin. So just I want to rotate about fixed point. That's why I'm giving the option 1. Just look at this output. So name is triangle rotation. So look at this initial, as I said, no, initial triangle will be like this, and so I'm going to specify with yellow color. Okay, so the first GL color 3 of function. So this is my initial triangle. Now I want to rotate this triangle by 90-degree. Just look at this. So this 90-degree means this will go to here. So this just, you can understand, right? Just if I taking this triangle and if I rotate it for 90-degree means it will looks like this. So in order to differentiate, you can do with the yellow color only, but you will not understand which one is initial one, which one is rotated one. So for that we are giving the different color. So now this is initial, and after rotate, see, look at this 90-degree. So 90-degree, for 90-degree angle, so this triangle is going to be rotated. And as I said, this is 100 comma 100 with respect to this is the x-axis, and this is the y-axis with respect to this xy plane. So this will be 100 comma 100, that is the fixed position. Okay, so I have rotated this triangle. Okay, so I'll come out. Next I will execute once again for the second choice. Again 90-degree only I'm going to give. So but I'm giving the option second, that is about the origin. See, based on the centroid calculation. So you don't look at this diagram should come here. No, not, it is not like that. So it should not come, it should not start from here. So here centroid it is going to calculate x with respect to that it is going to rotate. Okay, so because previous case, look at that, it is not overlapped. So the triangle whatever you saw in the previous output, so this is separate, this is both are both are separate only. So the yellow color will be here and red color will be here, but this is not like that. With respect to the centroid origin it is going to rotate. So look at this purple color, maroon, this is how it will be. See, so this is about the origin, just it has to tilt 90 degrees. See, now this will be the reference point. Understood? So with that, so you are, so just you have to assume, I can't show here how to rotate, but you should assume. So this is the yellow color initial. If you just rotate by 90-degree with respect to the centroid, that is what we calculated h and k value, the summation of the x coordinate value of all the x and 3 vertices and divided by 3, and similarly for y. Okay, so if you do like that, then your triangle will be rotated like this. This is about the origin, with respect to origin with centroid concept. Okay, so like this we can give. So you can give for another different rotation angle also. So just give like some 50 degree. Again option 1. See, like this you will get. This is with respect to 50 degree. Just look at this one. So this is the 50 degree. The previous case it is exactly 90 like this. Now it is 50 degree. So same thing you can execute for some other one. Again 50 degree, but with respect to origin, like this. So like this you are going to perform the triangle rotation. Okay, so just you try from your end. If you did not understand any function in this, please let me know. So I will try to make you understand. Okay, thank you.